let's start with a new topic, which is T flip-flop. What are the applications of T flip-flop? What all kind of T flip-flops can be used? So we can check out the application. The most important application for T flip-flop is frequency division. That is, it is used in counters where normally we have to check out the counting of the frequency or the counting of clock pulses wherever it is required. So the first is T flip-flop, which is we'll study in detail what exactly is the T flip-flop, how it operates. So the first, let's see in precisely how the circuit is and how it works, and then we'll study in detail what are the characteristic equations and how all the things or the calculations done in the T flip-flop. Let's see, T flip-flop has one clock, as it is a synchronous. We can see it is a edge triggered, which is symbolized by a triangle, and it is a positive edge triggered flip-flop. The same can be seen from the clock diagram and the output. That is, the clock, that is, output changes with the positive or with the rising edge of the clock. The same can be seen here. We can see in this case, these are the rising edges of the clock, the rising edge of the clock, the rising edge, the rising edge, the rising edge. That is, the output Q changes when the clock changes from 0 to 1, and again the output changes when the clock changes from 0 to 1. So the same can be seen here. The clock changes, as the clock changes from 0 to 1, the output changes from 0 to 1 and remains till the next cycle, that is till the next time when the output changes from 0 to 1. This, the same can be seen here, 0 to 1, the clock again changes here from 0 to 1, clock again changes from 0 to 1, clock again changes from 0 to 1. The application what we see, that is divide clock frequency by 2. This is suppose T, the clock here is 2T, that is the change of the output of flip-flop, T flip-flop, is equal to 2T. Therefore frequency here will be 1 by 2T, which is equal to F by 2, also called as divide clock frequency by 2. Hence is the application for the T flip-flops. Let's start off with the characteristic equation of the T flip-flops, or the truth table for the T flip-flops. Now the basic circuit of T flip-flop can be drawn directly as 0 to 0. It can be written as J, K. This is for T flip-flop. K, Q, Q is Q bar. Okay. And the truth table for T flip-flop is T, Q plus 0, Q, 1, Q bar. That is, when the input is 0, the output, the next output will be the current output present in the memory. Similarly, when T is 1, the next output will be the complement of the current output in the present memory. That is what the truth table of T flip-flop is. Now let's find out the excitation table, characteristic table, and characteristic equation. Now characteristic table, 0 0 0 1 1 0 1. T will be 0, this will be 1, this will be, I'm extremely sorry for this. Let's check out for the characteristic table. Characteristic table consists of input, the current input, and the pass output. See, 0 0 0 1 1 0 1 1. So when T is 0, we can see from the truth table, the output, the next output will be the current output, which will be Q. Here it will be 1. Similarly, when T is 1, the next output will be the complement of the current output. In this case, it it will be 1, and in this case it will be 0. So this is the characteristic table for T flip. Now to write down the excitation table of the T flip-flop, we can write down as excitation Q plus T. Excitation table is the table which consists of present output, future output, and T. So let's take up with different values 0, 0, 0, 1, 1, 0, 1, 1. That is, Q is the output as 0. We can take it from here. How this 0 comes? Let's take it from here. 0, 0, T gives 0, so we write it 0. 1, 1, T gives 1. So for this 1, 1, T gives 1. Similarly, we can get the value for 1, 1. Sorry, for 1, 1, yeah, the T gives 0. Similarly, for 0, 1, that is for this 0, 1, for this 0, 1, T is 1, and for 1, 0, the T is 1. So this is the excitation table, this is the characteristic table, and if we make the K-map for the characteristic table, we get the characteristic equation as, therefore the characteristic equation for T flip-flop can be written as T bar Q plus T Q bar.